Good afternoon. I have some friends here that's going to help me do an experiment, my science experiment. They're going to put it into action. They're trying to get a better understanding. The objective of this game is help them get a better understanding of Newton's three laws of motion. What can you tell me about Newton's three laws of motion, Thomas?
Newton's three laws of motion. Well, I think what the first one is that the object in motion will stay in motion, the object at rest will stay at rest until another force acts upon it.
Brianna, what can you add to that about Newton's three laws? Does the mass, the size of an object that hits another object has something to do with it?
Um,
Will it cause acceleration?
um, I think the bigger the mass of the object, it will make the other object move faster.
Good. Okay, now we're going to put this science experiment to test. We're going to test it out. Okay, we have the marbles placed in an X, one student on the left and one student on the right. The rules of the game are you shoot your marble. If it hits a marble and knocks it outside of the circle, you get to keep that marble. The next player goes. If your marble missed and rolled outside of the circle, you have to wait until the next player has done with her turn, and then it'll be your turn next. So we're going to have Thomas to go first, and we're rolling the marble to see what happens when you hit another marble. Let's go. Okay. What took place, Thomas? Can you describe what took place?
Yes, ma'am. What happened was this particular marble right here, which I hit with this particular marble, rolled out because this one had force and it knocked it out of these little.
So you get to keep that marble, right?
Yes, ma'am.
Brianna, your turn. So you have to roll your marbles into see what motion. Whoa, what happened with Brianna? Thomas, what happened with Brianna?
All of her energy went through each marble and it broke it apart. All the energy.
Why do you think she made more marbles move?
Because she rolled it faster and hit it right here.
You said faster, so the faster, what that mean?
The faster, the more acceleration it has.
And more, what's going to happen?
Acceleration, the more force it has.
The more force it has. Okay, Thomas, we're going to let you try again.
Okay.
Okay, what did you do different this time? I see you move more marbles. What did you do different?
I gave it a little more push and I hit it from the back, not from the side.
Okay. Good job, Thomas. Brianna, your turn. Okay, Brianna, I see you knocked two out of the circle. What did you do different? Did you put more force into yours?
Yes, ma'am.
You put more force, okay. What do you think will happen if you do it really, really slow?
Can I test it out?
Let's let Thomas test it out. What was the difference, Thomas? What happened different?
Nothing happened. It just kind of like just bumped like that.
Why? What do you think?
Well, my hypothesis or guess would be that when it tapped the other marbles, that there wasn't enough energy to go through all the marbles like previous time, so not a lot of them moved.
So you didn't have as much acceleration this time,
or force.
Okay. So tell me how you saw the three laws come into play with playing this game.
Well, what I saw was that an object at rest will stay at rest. An object in motion will stay in motion.
So how about if you roll your marble past it? What would happen?
Well, just like this.
What would happen?
Nothing, because none of the marbles either made contact.
So those marbles at rest will do what?
Stay at rest until another, as these right here are demonstrated, these are still good because nothing has hit them. But as for these and these, we've hit it from this side and this side, which makes them break apart. Yet none of these right here have been hit, so they are still in a straight line.
Good job. So I want you to think about other times that you have saw the laws of motion, Newton three laws of motion in a real life situation? Thomas?
A person going down escape ramp.
Mm-hmm.
Escape ramp. A lighter person with and a heavier person. The heavier person tends to seem have a less acceleration, but the lighter person has more acceleration. Yet they don't go that far, but the slightly heavier person goes farther because they have a more mass, which their acceleration might be fast, but they still have a lot more force, so they can go farther.
Okay. Brianna?
Like I've seen it when you stack dominoes in a row, and then you knock one down, and then knocks the other one.
So that one motion causes.
All the dominoes were at rest until an unbalanced force pushed one domino over and made all the other.
Good job, guys. I think this game and the real life experiments that you have had has truly given you a better understanding of Newton's 3 laws of motion. Thank you for playing my game. Have a good afternoon.